What if I told you that Starship's shiny ceramic heat shield might already be on its way out? That's right, SpaceX is now experimenting with metallic heat shield tiles, testing a bold new approach that could redefine spacecraft reusability. This new metal-based heat shield is predicted to be 3 times more durable than the ceramic version, and that durability is crucial for ensuring that Starship can be reused multiple times without major repair work. Elon Musk, as always, is looking for new ways to reduce cost and improve performance. And that's exactly what this new direction aims to do. With reusability at the heart of Musk's space ambitions, finding a shield that not only withstands intense heat but also lowers turnaround time is vital. From the very start, Musk's mission with SpaceX has been clear: lower the cost of space travel by making rockets reusable. It sounded ambitious at a time when space launches were rare and wildly expensive. Most people thought it couldn't be done. But now, thanks to breakthroughs like Falcon 9's reusable boosters and Starship's all-in-one architecture, reusability is becoming the new standard. However, sending a spacecraft up is only half the battle. The real challenge is bringing it back intact. Re-entry from space is violent and unforgiving. The vehicle slams into the atmosphere at hypersonic speeds, creating temperatures that can melt almost anything. Without a strong and reliable heat shield, the craft would simply disintegrate during descent. Starship is designed to withstand this chaos. Its belly is covered with around 18,500 ceramic tiles, many of which are shaped in a hexagonal pattern. These tiles can handle temperatures near 3,000 degrees Fahrenheit and are designed to be reused, unlike the ablative heat shields used on vehicles like Crew Dragon, which burn away with each flight. The ceramic tiles are mounted directly to Starship's 304L stainless steel body. This steel not only adds strength and resistance to heat on its own, but it also reduces maintenance and repair time. It's a smart design that combines thermal resilience with practicality. Together, they create one of the most advanced thermal protection systems ever put on a spacecraft, one that allows Starship to survive and be reused multiple times. This approach isn't entirely new. NASA's Space Shuttle also used a tiling system to manage heat during re-entry. The shuttle's black tiles were made from high-purity silica fibers and worked well for decades, protecting the orbiter during countless missions. The black color of the tiles is actually functional, not cosmetic. According to physics, black surfaces radiate heat better than lighter ones. That radiation helps bleed off the massive heat generated during re-entry, keeping the vehicle's core structure cooler. So, in a way, Starship is continuing the legacy of the Space Shuttle, but aiming to do it faster, cheaper, and better. It's one of those rare moments where aesthetics and function are perfectly aligned because in this case, looking cool also keeps you alive. But ceramic tiles are far from perfect. They're brittle, prone to cracking, and hard to manufacture in large sheets. That's why SpaceX, like NASA, uses thousands of small tiles instead of a single big one. This modular design allows for more flexible coverage and easier replacement of damaged sections. Each tile must be precisely mounted using high-temperature adhesives or mechanical fasteners. And this is no easy job. If a tile is slightly misaligned or improperly secured, it risks falling off during flight, an error that could result in catastrophic failure. Elon Musk even joked once that the Starship's belly was like a bunch of dinner plates glued to a rocket that's shaking like hell. And he's not wrong. The vibration, G-forces, and thermal cycling can wreak havoc on these tiles. Ceramics also suffer from thermal cycling. As the tiles heat up and cool down over multiple missions, they expand and contract. Over time, this can cause cracks or loosen tiles, making them unreliable. After each flight, engineers must inspect every single tile individually. Even if just a few are damaged, replacing them adds time and cost, 2 things SpaceX wants to eliminate in the future. That's what makes the new metal-based heat shield idea so promising. A metallic heat shield could simplify everything. Fewer inspections, less maintenance, and possibly a system that lasts much longer without degrading. The goal is rapid reusability, being able to land, refuel, and fly again with minimal downtime. Using metal as a heat shield may sound counterintuitive to some, but it's an idea SpaceX has been playing with for years. Metal typically conducts heat well, which might seem like a bad idea for a shield. But when engineered correctly, it can work wonders. In fact, Musk teased the idea as early as 2019 when he released a test video showing a metal heat shield enduring flames at temperatures nearing 2,000 degrees Fahrenheit. In that video, the glowing metal didn't warp or crack. It held its form, glowing red as fire raged around it, a clear demonstration of its potential. The footage was impressive, showing that under controlled design conditions, metal could resist the kind of heat that space re-entry delivers. While it may not be ready to replace the current ceramic system just yet, this test showed that metal could be the future of spacecraft heat shielding. The promise lies in fewer tiles, fewer weak points, and a longer-lasting system that supports the rapid reusability model SpaceX dreams of. Instead of checking thousands of brittle tiles, engineers could one day inspect fewer, stronger metal plates. If successful, this transition could revolutionize spacecraft design. It could mean faster launch cycles, lower costs, and safer re-entries. It's another bold experiment in a long line of innovations from a company that refuses to settle for good enough. For SpaceX, the heat is on, but that might not be a bad thing after all. What if I told you that Starship's shiny ceramic heat shield might already be on its way out? Sounds surprising, right? But it's true. SpaceX, the company known for pushing the boundaries of space technology, is already testing a bold new idea that could transform how we think about spacecraft reusability. Instead of sticking with the fragile ceramic tiles we've all come to associate with Starship, the company is now looking into metallic heat shield tiles. Yes, metal. And if everything goes according to plan, these new tiles might just replace the old ones entirely. They're predicted to be up to 3 times more durable than the current ceramic versions, and that kind of durability is a game changer. It means Starship could fly again and again without needing massive repairs in between missions. This isn't just a cosmetic tweak or a minor engineering adjustment. It's a complete shift in how we think about protecting spacecraft from the brutal heat of re-entry. Elon Musk, as usual, is at the forefront of this change, pushing his team to find ways to reduce costs, improve performance, and make spaceflight as routine as commercial air travel. And at the heart of that vision is reusability. For Musk, a rocket isn't truly useful unless it can fly multiple times with minimal fuss. That's the only way we'll make meaningful progress toward colonizing Mars or making space tourism a real industry. And to achieve that, the heat shield, arguably one of the most critical parts of any spacecraft, must evolve beyond what we're using today. From the very beginning, Musk's mission with SpaceX has been crystal clear: lower the cost of space travel by making rockets reusable. At a time when launching into space meant spending hundreds of millions of dollars on a rocket that would be thrown away after a single trip, that idea sounded almost ridiculous. Most experts were skeptical. Some outright laughed at it. But look at where we are now. Thanks to innovations like the Falcon 9's reusable boosters and the fully integrated Starship system, reusability is no longer a wild dream. It's rapidly becoming the industry standard. And that means the expectations for spacecraft hardware are higher than ever. It's not enough to survive one flight. These machines have to endure multiple missions back-to-back without needing a full rebuild. Of course, getting a rocket into space is only half the battle. The real challenge, the part that separates the good designs from the great ones, is bringing it back safely. Re-entry is a brutal process. When a spacecraft returns to Earth, it slams into the atmosphere at hypersonic speeds, facing temperatures that can melt nearly anything. It's a fiery descent, and only the toughest materials can withstand it. That's where the heat shield comes in. Without it, even the most advanced rocket would burn up in seconds. So it has to be reliable, strong, and capable of performing flawlessly flight after flight. Right now, Starship is using a heat shield made up of about 18,500 ceramic tiles. These tiles are mounted across the vehicle's underside, its belly, where the heat of re-entry is most intense. They're arranged in a hexagonal pattern, carefully designed to minimize gaps and maximize coverage. Each tile is capable of withstanding temperatures near 3,000 degrees Fahrenheit. Unlike the ablative heat shields used in older spacecraft like NASA's Apollo capsules or the more recent Crew Dragon, Starship's ceramic tiles are designed to be reused. That's a massive improvement because ablative shields burn away during flight and have to be replaced entirely after each mission. Reusable tiles are far more efficient, at least in theory. These ceramic tiles are attached directly to Starship's stainless steel body, which uses a special alloy called 304L. This stainless steel isn't just for looks. It adds strength and thermal resistance, allowing the vehicle to endure the harsh conditions of spaceflight and re-entry without becoming too heavy. The steel also helps reduce the amount of maintenance needed between flights. It's a clever combination of durability and practicality. Together, the steel body and ceramic tiles create one of the most advanced thermal protection systems ever used on a spacecraft. It's what allows Starship to survive the heat, return to Earth, and potentially launch again in a matter of days. Interestingly, this idea of using a tiling system for heat protection isn't brand new. NASA did it decades ago with the Space Shuttle. The shuttle used thousands of black tiles made from high-purity silica fibers. These tiles serve the same purpose: protect the vehicle during re-entry. They worked incredibly well and helped make the shuttle partially reusable. In fact, the black color wasn't just for aesthetics, it played a functional role. According to the laws of physics, black surfaces radiate heat more efficiently than lighter ones. That means they help shed the heat of re-entry faster, keeping the internal structure of the spacecraft cooler. Starship is essentially continuing the legacy of the space shuttle, but with newer materials and more ambitious goals. But let's be honest, ceramic tiles aren't perfect. In fact, they come with a whole list of problems. First, they're brittle. That makes them prone to cracking or chipping, especially during the violent vibrations and forces experienced during launch and landing. That's one reason why both NASA and SpaceX use thousands of small tiles instead of fewer large ones. If one tile breaks, it's easier to replace a single small piece than a massive one. But the downside is obvious. You now have thousands of individual parts that can potentially fail. And each one must be precisely installed. If a tile is slightly off, it could fall off during flight, a risk no one wants to take. The mounting process itself is incredibly demanding. Each tile needs to be installed with high-temperature adhesives or mechanical fasteners, and the tolerances are tight. Even the smallest misalignment can lead to disaster. Elon Musk once joked that Starship's heat shield looked like a bunch of dinner plates glued to a rocket that's shaking like hell. That's both funny and concerning because he's not wrong. The forces during ascent, orbit, and re-entry are enough to loosen anything that isn't perfectly secured. And that adds to the engineering headache. Another issue with ceramics is thermal cycling. As these tiles heat up and cool down over multiple flights, they expand and contract. That constant stress can cause microcracks to form or weaken the adhesive bonds over time. Even if just a few tiles are damaged, they must be repaired or replaced. And that means inspecting every single tile after each flight. It's a time-consuming process that adds delays, costs, and complexity, three things SpaceX is trying to eliminate as it moves toward rapid reusability. This is where the idea of a metallic heat shield becomes so attractive. Unlike ceramic tiles, which are delicate and high maintenance, metal could provide a more durable, unified solution. Instead of having to check 18,000 plus tiny parts, engineers might only need to inspect a smaller number of large, robust plates. A metallic shield could also be easier to manufacture and install. And if it can survive multiple flights without significant wear, it would reduce downtime dramatically. Imagine a future where Starship lands, gets refueled, and launches again within days, all without needing major tile replacements. That's the dream SpaceX is chasing. Now, using metal as a heat shield might sound counterintuitive. After all, metal conducts heat really well, right? Isn't that the opposite of what you'd want on a heat shield? Well, yes and no. It's true that metal conducts heat, but if it's engineered correctly, that property can actually be used to an advantage. SpaceX has been quietly exploring this idea for years. In fact, back in 2019, Elon Musk released a video showing a prototype metal heat shield being blasted by intense flames. The metal glowed red, but it didn't melt, warp, or crack. It held its shape under incredible heat, proof that the concept wasn't just theoretical. That video demonstration showed the heat shield reaching temperatures near 2000 degrees Fahrenheit. It was an early test, but it looked incredibly promising. If a metal plate can endure that kind of punishment without falling apart, then it's more than just an experiment, it's a potential revolution. And considering that metals can be manufactured in large, uniform sheets, the entire heat shield could be simplified. Instead of dealing with thousands of ceramic tiles that must be perfectly aligned and carefully glued, a metal heat shield could offer fewer points of failure and a much faster installation process. We're not there yet, of course. Right now, the ceramic tile system is still the main heat shield design for Starship, and it's flying on the latest prototypes. But SpaceX is clearly preparing for the next step. The metallic heat shield may not be ready to take over today, but it's being developed with the future in mind. If the tests continue to go well, we could see a gradual transition over the coming years. And once the metal system proves it can handle full orbital re-entries reliably, it could become the new standard, not just for Starship but for other spacecraft as well. This kind of innovation is what sets SpaceX apart. They're not content with just doing what already works. They're constantly asking, how can we do this better? Whether it's landing boosters on drone ships, building rockets out of stainless steel, or experimenting with new heat shield technologies, SpaceX is always pushing the envelope. And sometimes, the wildest ideas, like using metal to shield a rocket from atmospheric re-entry, turn out to be the smartest. So what does all this mean for the future of Starship and space travel in general? If the metallic heat shield works as expected, it could drastically shorten turnaround times between flights. Instead of weeks of inspections and repairs, engineers could run quick diagnostics, confirm the shield's integrity and send the rocket back to space within days. That kind of operational tempo would be revolutionary. It would make launching into orbit cheaper, faster, and more routine, paving the way for everything from interplanetary missions to commercial spaceflights. SpaceX isn't just building a rocket. They're building a system, a platform that can make space accessible in a way we've never seen before. And whether it's covered in ceramic tiles or futuristic metal plating, Starship is shaping up to be the backbone of that vision. One thing is clear: when it comes to innovation, SpaceX doesn't shy away from the heat. They run straight into it,